Hello, my name is Dylan Antelm, and for my Calculus BC final, I'll be doing disks and washers.
Ah, boy, here we go.
Disks. The simplest case is when R is the area under a curve. Y equals f of x between x equals a and x equals b, revolved around the x-axis. Washers. For washers, you'll be generating a region R bounded by two functions, y equals f of x on the top and y equals g of x on the bottom. For example 1, use the method of disks/washers to determine the volume of the solid obtained by rotating the region bounded by y equals 7 minus x squared, x equals negative 2, x equals 2, and the x-axis about the x-axis. For example 1, we'll be using the disk method, which is v equals pi times the integral from a to b of fx squared dx. Plugging in the variables, we get v equals pi times the integral from negative 2 to 2 of 7 minus x squared dx. First solving the integral from the previous slide, we get pi times the integral from negative 2 to 2 of 49 minus 14x squared plus x to the fourth dx. Getting the antiderivative of that, we get pi times 49x minus 14 over 3x cubed plus 1/5 x to the fifth from negative 2 to 2. Finally, solving the antiderivative from the previous slide, we get 2012 over 15 pi.
Here we go again.
For example 2, use the method of disks/washers to determine the volume of the solid obtained by rotating the region bounded by y equals 2x squared and y equals x cubed about the x-axis. For example 2, we'll be using the washer method, which is v equals pi times the integral from a to b of f of x squared minus g of x squared dx. Plugging in the variables, we get pi times the integral from 0 to 2, 2x squared minus x cubed squared dx. Simplifying the integral from the previous slide, we get v equals pi times the integral from 0 to 2 of 4x to the fourth minus x to the sixth dx. Getting the antiderivative of that, we get pi times 4 over 5 x to the fifth minus 1/7 x to the seventh from 0 to 2. Finally, for example 2, solving the antiderivative, we get 256 over 35 pi.
Yes, finally.
Example 3. Find the volume of the solid obtained by rotating the region between the graphs of y equals x times 2 minus x to the power 1/2 and y equals 0 about the x-axis. For example 3, we'll be using the disk method. Plugging in all the variables, we get v equals pi times the integral from 0 to 2 of x root 2 minus x squared dx. First, simplifying the integral from the previous slide, we get pi times the integral from 0 to 2 of 2x squared minus x cubed dx. Getting the antiderivative of that, we get pi times 2/3 x cubed minus x to the fourth over 4 from 0 to 2. Finally, solving the antiderivative from the previous slide, we get 4/3 pi.
Now that's a lot of damage.